Well, thanks very much for joining this already third webinar in the series for the EUDIS Hackathon. Um, so today we have two speakers, which I will announce later. I first will brief you a bit about the current registrations. So currently we have over 50 people registered for the event, so which is quite nice. And well, registration deadline is on the 10th of October. Most likely it will be extended. So I think the group will be quite big for this hackathon. Okay, then let me share my screen. Yes. You see my screen, right? The PowerPoint.
Yes, we can see your screen.
It's in presenter mode. Yeah, okay. All right, good. So, yes, this webinar is the third one, as I said. So what are we going to do today? After a brief introduction from my side, we have Benji Metz from the Vydar group. He will give a brief presentation about activities of Vydar, how did they start the company, and current applications. Then a short Q&A. Unfortunately, Benji has to leave after that because there's the 20th anniversary of Yes Delft, and the background noise is people having already the borrel, so he has to join it. Then a bit after 4:30, we have Tsjerk Walinga from the company iPlane, developing software and tooling regarding synthetic data and AI modeling for object detection. Also Q&A session afterwards. If anyone feels free or has specific requests, you can use the 1-minute pitch slot, and this will most likely result in some kind of an open discussion about hackathon topics or themes. So I think based on previous experience, we will end the session about 5:15. Oh, and I have to admit, oh, there's Tsjerk. Yes. All right, Tsjerk, welcome. Then after, why is my computer not working? Okay, so the hackathon is not organized by DotSpace alone. It's a multi-stakeholder partnership of Ministry of Defense, of course, then NL Space Campus, then Economic Board of Duin and Bollenstreek, the Province of South Holland, Innovation Quarter TNO, NLR, and SBIC, the incubator. And all these parties who are involved will also provide mentors during the hackathon weekend. So especially from TNO and NLR and the Ministry of Defense, these are the experts on the technology domain. And for example, Innovation Quarter will provide advice or insights in the funding landscape, especially also of the SEC fund, because there's a representative around during the weekend. So today we focus on the topic of sovereign aerospace, so unmanned aerial vehicles and countermeasures. And I think today we're especially focusing on the developing drone management hardware and software related to navigation and so on. But of course, there are more topics which could be considered as a challenge during the hackathon. In the first two topics, the main theme, protection of space assets and space for defense, were covered in the webinars which we did before. So, and these are available on YouTube, or if you can't find it, please send me a note and I can send you the link. Okay, so where will this event take place? You see a bit of a difference with the slides from last webinar, in case you follow this one, because there's a collaboration between the Comet Lab and the Business Incubation Center. So facilities will be available at Comet Lab, and most likely some teams can also work in the incubation center in Noordwijk. It's all in walking distance, so over the weekend you will maybe lose 10-15 minutes if you have to go from one building to the other. So that's quite doable. Furthermore, we offer accommodation. We've made an arrangement with a hotel in Katwijk. If you're looking for accommodation for 30 euros for the full weekend per person, we can offer you a stay, including 2 times breakfast. So if you want to use this, then please send an email to me or to hackathons@groundstation.space. So in the Comet Lab, some material is available. But if you have specific needs for your prototyping, then my advice is to bring it your own. So which means you don't have to share, which might be handy. It might be possible that not the specific equipment is there which you need. So be aware of this. And as said, so we have several mentors. So from Mind, Ministry of Defense, TNO, NLR, Aquahub, which is the winner of the spring edition of the EUDIS Hackathon. So they won the European competition. So in the first webinar, Carol gave some great tips also for pitching and so on. So have a look at that. And we have many others available. And in the coming weeks, an agenda will be ready, which states which mentor is around on which day and which time slot. Then we have, of course, a jury chaired by Ministry of Defense, and then with the members representatives from economic board, industry, research institutes, companies, and asset investment manager from the SEC fund. We also will be having some local talks during the Friday afternoon. So after the central opening, there will be kind of a local plenary opening and one speaker which will give a vision or view on developments. Will be or is Mr. Scott Ackerman, and he is from the Aerospace Forces Command of the Ministry of Defense. So he can provide real insights in priorities, especially for the Dutch armed forces. And of course, we have a prize package, some prizes, monetary prizes, but I think the most interesting part is, of course, the support from the experts from TNO and NLR. And what we have added to the package is we can award the first and the second prize with a participation in a DroneAid workshop, which will be more explained in the next webinar. But it's like the assembly of drones, which will be used, for example, for reconnaissance missions in Ukraine. And the hackathon originally or officially starts at 3 o'clock, but before this, we organize a pre-event, which takes place from noon till 3 o'clock, and that's the drone assembly workshop. This is in collaboration with DroneAid Collective, and we have made available 8 to 10 seats for participants of the hackathon to just to assemble the drone under the guidance of the experts from the DroneAid Collective. DroneAid Collective heavily supports also other hackathons, defense hackathons throughout Europe, and they're active in the Netherlands, but also in Portugal and in Germany, and of course in Ukraine. And more information will be given in the webinar of next week. If there's an interest from people who don't have the intention to join the hackathon, then they're more than happy on this pre-event, but then the drones have to be acquired, and DroneAid asks a contribution of 400 euros per drone. So it's an open event, but with a preference for hackathon participants. So this is my last call to action. So I will stop sharing my screen, slides, and then I give the floor to Benji, one of the founders of the Vydar group, and we met during last year's CASSINI Hackathon, which we organized as well regarding the topic of space and security and defense. So, Benji, the floor is yours. Are there any questions? Feel free to ask now or later.
All right. Perfect. Thank you, Martijn. Thank you for the introduction. Yeah, I just wanted to give some context on why we're here. So, first of all, as Martijn said, we got in touch because of the last CASSINI Hackathon. And that hackathon we took part of that hackathon, and then we got first in the Netherlands, and then second in the European match. And from there, we started the company, and that's how we got funding, and we got an office, and yes, Delft, and we went to Ukraine with our idea. I think, can you guys share screen? Can you see my screen? Can you see my screen?
Yeah. Yes.
Perfect, thanks. So we won that hackathon with our idea on GPS denied navigation using artificial intelligence. First, the problem statement, because why do you need AI for GPS, for flying in GPS denied areas? Well, currently, all of the conflicts in the world, the modern conflicts, have some type of communication jamming, mostly GPS jamming, which causes thousands of drones to fall out of the sky, and that's significantly important. That's significant because because Ukraine itself, by itself, is using 10,000 drones a week, and because of that jamming, they're just falling out of the sky, causing a mission success rate of 20%. And with our solution, we are able to get those drones to fly again with a 20-meter accuracy. And so what does that look like? It looks like this. We basically take an image of the ground. We use our artificial intelligence pipeline to extract the GPS coordinate from that, and then we are able to fly again. And so in this demonstration, you can see that a drone shown in the red, which is collecting images. This red line is the GPS coordinate, and the green one is the coordinate that we're predicting. And we're predicting this on 20 meters accuracy on a 1,000 square kilometer satellite map. And to put that in perspective, if you go outside with your phone, you have an accuracy of 10 to 15 meters. And if you're in a in an area with a high inference or interference, you basically have 40 meters accuracy. So think of London, New York, Berlin, or the Dolomites because of the interference. And we do this on self-made custom hardware. That hardware is swap optimized, so size, weight, and power optimized, but also cost optimized. Because currently, any AI that is run on edge is done on a NVIDIA Jetson, and those, as you can see here, the NVIDIA Jetsons are much more power inefficient. They're much heavier. They're also much more costly, and that is important because drones are getting much cheaper, but there's no hardware being built that's able to run artificial intelligence cost efficiently. And so even with hardware that's 30 times less powerful, we get Jetson class accuracy and the same speed. Another thing that's super important with this is that NVIDIA Jetsons, they have kill switches or potential kill switches, but definitely do have trackers, as you can see in the article Reuters released. And so we also decided to develop everything within Europe, 100% sourcing all of our components from Europe, which is very important in like current geopolitical state of the world. But because we're using less powerful hardware, doesn't mean we have less capabilities. Because even with that less powerful hardware, we're able to do any of the artificial intelligence on edge applications that you would require on the battlefield in Ukraine. So we do terminal guidance, we do drone interception, we do military grade night vision. That's only with digital processing and not even with night vision sensors. And then we also want to we want to develop a distributed sensor system that's able to filter any of the data and send it to a central system. And yeah, that's actually my presentation. Are there any questions?
Yeah, I have one question. How does this work at night? Because then there are no points of navigation, I guess.
Yeah, so that's a good question. We've deliberately chosen to do it with normal optical sensors because you can get the price down far enough. As I said, drones are getting cheaper, and night vision sensors are just very expensive. You do have the the FPV night vision, but those don't go as far as you need them to go, and they're very noisy, so they're also not really good for navigation. But that being said, the stack we've developed is modular. So if you have a more expensive drone that has night vision or thermal cameras, you'll be able to just attach it to our modular stack, and then we can process that and generate GPS coordinates.
Cool, thanks.
You're welcome.
And how do you update your software when it's on the edge? Because that's quite a problem, I guess. Or can be problematic.
We don't need regular software updates. It's basically for either for one-way drones, or if you have a more expensive system, then the software should still be applicable to any system. And it's just the software package you run, and you basically get a GPS coordinate for it. So it's does that answer your question? Or
yeah, that's fine.
Perfect. Yeah.
Okay. There's a question in the chat from Magdalena, or is it related to iPlane?
Oh yeah. So what data we use is just normal optical satellite maps. Sorry for the noise in the back. We don't need other data. The rest of the data we can get from our internal systems.
Okay, so yeah, it was a question for you, so that's good.
Perfect.
I've got another question, Benji. Of course, we focus on the defense side. Of course, we have the aspect of dual use, which most likely comes from the civil domain into the defense side, but you can also flip the coin. What kind of other sectors would be relevant for you to pursue?
Great question. Thanks for asking. Basically, any application where you need AI on edge. That's basically it. If there's a commercial application that you require, we can do it, but we do have to tweak your model to be able to run it on constrained hardware.
So you're not fully attached or linked to drones or unmanned flying systems?
No, absolutely not. The reason we're developing it is for the drone, for the drone industry, but it's not restricted to the drone industry.
Okay, good. And you also will participate in the hackathon, eh? With your team. Do you look for any other partners within your team, or any team members, or are you?
Oh, that's a good question. There's no real no real need for for it, but it could always be interesting. So if you would like to join our team for this hackathon, then you're welcome to join, or at least ask. Thanks for
No start with asking. Yeah. Okay.
You got an applause for your answer.
Yeah.
Yeah. All right. Are there any more questions you want to ask Benji, or remarks, or if not, we can also follow or continue the discussion on the hackathon platform on Discord or Taikai. Yeah, then Benji, thanks for your contribution today.
Yeah, no worries. It was a pleasure to be here. If you guys have any questions or whatever, I've sent my email address in the chat.
And we will also share the slides afterwards, so then your contact details are there.
Perfect.
Yeah, so that's fine. All right, then thanks a lot.
All right, guys, thank you for having me.
Then
Thank you for
I know you
having
have
me.
to leave, so see you in a few weeks. And then we quickly move on with Tsjerk, who did arrive in the
See you guys.
meeting. Yeah, bye. So Tsjerk is from the company iPlane, and he will also present the developments of iPlane and maybe specific needs or requirements or opportunities, and they will also participate in the hackathon this October. So, Tsjerk, the floor is yours. The share slide is on the bottom of the screen.
Yeah, I see it.
Okay, good.
1 second. I have to allow sharing my screen. Oh, it says I can't share my screen. Wait a second.
I see myself multiple times, so.
Okay, can you see my screen?
Yeah.
Yeah. Okay. And you can also see the slides, right?
Go ahead, floor is yours.
Okay. So so let's first talk about me. I'm Tsjerk Peter. I'm a synthetic data engineer at iPlane, where I mainly make procedural environments and automatic training data generation. And for this, we use like Blender and GenAI, like recently. What iPlane does is we make detection software for automated aerial detection. So having a UAV fly autonomously and detect automatically and send those over. And iPlane started with a project where they tried to monitor wildlife and detect trespassers. But this has now moved into detecting military vehicles using synthetic data. And what I mean by synthetic data is that you don't have any real photos, but you use a 3D engine or image generator to get training data for those detection models. Okay, then what are we doing at the challenge? our challenge is creating a synthetic data set for drone detection. So iPlane is currently working on detecting military vehicles from drones, but we want to try this challenge to detect drones from the ground using synthetic data. So the challenge will be to create a training and validation data set, completely synthetic, so no photos allowed. And then we'll have a test set where you can test it on real data during the challenge. What's difficult about this is that if you only use synthetic data, it's hard to generalize to real data. So it's easy to like have a model working on synthetic data, and then you use it real data, and it just classifies everything wrong, or doesn't detect anything, or detects birds as drones or something. And that's also the second problem, ignoring distractors. The skies aren't empty. There's birds, there's bugs, there's planes, there's whatever. And detecting drones and not detecting planes will be a challenge. And then once you've detected the drone, you also have to classify it. So know which drone it is, because you wouldn't want to shoot down your own drones. And then the practicalities of the challenge. The creation of the dataset will be done in your own hardware, so it's nice if you have a beefy laptop if you want to do anything using more advanced techniques. There are also methods to create data which don't use a lot of hardware. So choose your technique carefully. Then we'll provide a boilerplate code for training the model. So the model will be fixed, and the focus will only be on creating the data set. And we'll, of course, provide a test set so you can actually test your trained model. Then I have some example ideas. Okay, so with iPlane, we create a completely 3D environment for creating synthetic data. But there's loads more you can do. You can use existing 3D environments, for example, a game. In loads of papers, people use GTA 5 for data generation. You can also superimpose images, so just get an object of interest and just paste it on top of another image. And you can also use those new diffusion model image generators. Maybe you can get good results from those, although they will probably hallucinate some details. And my main takeaway is here, be creative in what techniques you use, because we like to see new techniques being used, and we would be interested in seeing what the result is of those.